Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss limits and derivatives. Okay, my dear children. In this chapter, we are going to discuss the sums in the exercise 13.1, page number 301 in the textbook. Okay, my dear children. Are you ready to listen the class? Right. In the previous class, we have discussed question number 8, 1 to question number 8. So far, we have completed 8 questions so far. I have given 9th question as homework. 9th question, 11th and okay, my children. 9th, 11th. I have given the 2 questions as homework. I hope you have understood the questions well. You have learnt well those questions. Okay, my children. Right. Now come to the question number 10. Question number 10. Evaluate as z tends to 1, limit z to the power of 1 by 3 minus 1 whole divided by z to the power of 1 by 6 minus 1. Understood this question, my children? Yes, we have to find the limit of this function as z tends to 1. Okay, my children. Right. Come to the solution part. As z tends to 1, limit z to the power of 1 by 3 minus 1 whole divided by z to the power of 1 by 6 minus 1 is equal to, what I said, first method is the substitution method. If you follow that method, you get here 0 by 0. Indeterminate form. I am not doing that one. You do that part. Okay, my children. So, substitution method fails here. We are not getting a finite real number. We are getting an indeterminate form. That is why we go to some other method. I told you in the previous class also clearly. We have to follow some other method. So, see here this function, it is in the form of a power m. We can write 1 to the power of 1 by 3. Isn't it or not, my children? So we are changing this function according to the standard limits. Okay, my children. So as z tends to 1, limit z to the power of 1 by 3 minus 1 can be written as 1 power 1 by 3. Okay, my children, understood that point? Right. Whole divided by, come to the denominator. Here also we can write z to the power of 1 by 6 minus 1 to the power of 1 by 6. Okay, my children, I wrote 1 as 1 to the power of 1 by 6. In the numerator, I wrote 1 as 1 to the power of 1 by 3. Okay, my children. Right. If you observe this function, it is in the form of a power m x power m minus a power m by x power n minus a power n. As x tends to a, x to the power of m minus a to the power of m by x to the power of n minus a to the power of n. What is the formula? M by n, a to the power of m minus n. Where x is equal to z, a means 1, m means 1 by 3 and n means 1 by 6. Okay, my children. So, m by n, what is m here? 1 by 3 by 1 by 6. M is 1 by 3 by 1 by 6 into a to the power of, what is a here? 1. 1 to the power of m minus n. So 1 by 3 minus 1 by 6. Because I am writing that standard limit formula. As x tends to a, limit x power m minus a power m by x power n minus a power n is equal to m by n, a to the power of m minus n. By using this standard limit, we wrote this step. Understood this step, my children? Right. Now we simplify this number. How can you write this number? 1 by 3 into, we write its reciprocal. Do you know this rule, my children? In the denominator, fraction is there. If you are writing in the numerator, we write its reciprocal. Into 1 to the power of, let us take the LCM. 1 by 3 minus 1 by 6. We have to simplify these two numbers. Means 1 by 6 is the LCM. 3 2 times, 6 1 times. 2 minus 1. Understood this part, my children? Right. Now let us simplify 3 1 times, 3 2 times. So after cancellation, what will you get? Finally 2 into 1 to the power of, what will you get here? 2 minus 1, 1 by 6. Understood this part, my children? Right. 2 into 1 to the power of 6 value is 1 only. So 2 into 1, that is equal to 2. So the limit of this function as z tends to 1 is 2. Understood, my dear children? Right. But my dear children, you should memorize the standard limits. You should learn well the formula of standard limits. Okay, my dear children, without knowing this one, you can't find the limit of this function. Understood this point, my dear children? Right. Now come to the next question, question number 12. Okay, my dear children, I have given question number 9 and question number 11. Do yourself the question number 9 and question number 11, my dear children. Yesterday itself, I have given the two sums. Okay, my dear children. Now come to the question number 12. Evaluate as x tends to minus 2, limit of 1 by x plus 1 by 2 whole divided by x plus 2. Understood this question, my dear children? Right. We have to find the limit of this function as x is approaching to minus 2. Right. Come to the solution part. As x tends to minus 2, limit of 1 by x plus 1 by 2 whole divided by x plus 2. Okay, my dear children. If you follow the substitution method, we get 0 by 0, indeterminate form. Okay, my dear children. I am not doing that part. You try it by substitution method, then you get 0 by 0 form. So we follow some other method. Okay, my children? Right. So as x tends to minus 2, limit, here I am simplifying. Here I am simplifying this one. What will you get here? 2 plus x by 2x. If you take LCM here, what will you get? 2 plus x by 2x whole divided by x plus 2. Understood this numerator part, my children? I have taken LCM, that is for x and 2x is the LCM, then we get 2 plus x. Understood this step, my children? Right. Then here x plus 2 gets cancelled. Okay, my children? Then as x tends to minus 2, limit, what is left here? 1 by 2x. After cancellation, we got this function. Now we follow substitution method. Okay, my children? Right. That is equal to 1 by 2 into minus 2. We are substituting x is equal to minus 2 because x is approaching to minus 2. So we substituted x is equal to minus 2 in this function. Then we get this step. Understood this step, my children? Right. Now let us simplify. What will get? 1 by minus 4. Understood this step, my children? Right. This can be written as minus 1 by 4. Understood, my children? Right. Now come to the next question. Question number 13. Evaluate as x tends to 0, limit of sin ax by bx. Understood this question, my children? We have to find the limit of this function as x is approaching to 0. Right. Come to the solution part. As x tends to 0, limit of sin ax by bx. Okay, my children? Right. If you substitute x is equal to 0, if you follow substitution method, we get the limit is in the form of 0 by 0, that is indeterminate form. So we should not get a limit of the function a indeterminate form. That is why we follow some other method. Okay, my children? Right. So here b is a numerical coefficient. I will write outside. So 1 by b, x tends to 0, as x tends to 0, limit sin ax by x. Isn't it or not, my children? Understood this step? Here b is a numerical coefficient we wrote outside. So 1 by b into as x tends to 0 limit of sin ax by x. So here we got a standard limit. It is a standard limit. Do you remember that formula, my children? 1 by b into a, because as x tends to 0 limit sin kx by x is equal to k. At the time of concepts of this chapter in the exercise 13.1 we discussed this point, standard limits. Do you remember this standard limit formula, my children? By using this formula we wrote this one where k is equal to a. Understood, my children? Right. That is equal to, let us simplify this number, a by b. This is the limit of this function. Understood, my children? Right. Now come to the next question, that is question number 14. Question number 14. Evaluate as x tends to 0 limit of sin ax by sin bx, comma a comma b is not equal to 0. Understood this question, my children? We have to find the limit of this function as x is approaching to 0. Okay, my children? Right. Now come to the solution part. As x tends to 0, limit of sin ax by sin bx is equal to, if you substitute x is equal to 0 in the numerator as well as in the denominator, we get 0 by 0. Previously I told you the limit of the function should not be indeterminate form. If you get an indeterminate form in the substitution method, we follow some other method. Okay, my children? Right. So that is equal to, as x tends to 0, limit, here I am dividing the numerator and denominator by x. Okay, my children? Sin ax by x whole divided by sin bx by x. Here I divided the numerator and denominator by x. Okay, my children? Understood this step? Right. Now we can find the limit of this numerator separately, we can find the limit of the denominator separately. So as x tends to 0, limit sin ax by x whole divided by, as x tends to 0, limit sin bx by x. Understood this step, my children? We are finding the limit of the numerator separately and denominator separately. Okay, my children? Understood? Right. If you observe the numerator, it is a standard form, as well as the denominator is also standard form. What is the standard form? As x tends to 0, limit sin kx by x. Previously we used that standard limit. Okay, my children? So what you get in the numerator? A only. A by, what you get in the denominator? B. Because as x tends to 0, limit sin kx by x, by using this standard limit we found numerator values a as well as denominator, the limit of this denominator is also b. Understood this step, my children? In the numerator we found the limit of this function is a, whereas the limit of this denominator is b. So a by b. A by b is the limit of the given function as x tends to 0. Understood, my children? Right. Come to the next question, that is question number 15. Okay, my children? Evaluate as x tends to pi, limit of sin pi minus x by pi into pi minus x. Understood this question, my children? We have to find the limit of this function as x is approaching to pi. Okay, my children? Right. Come to the solution part. As x tends to pi, limit of sin pi minus x by pi into pi minus x. Okay, my children? Right. If you observe here, pi is a numerical coefficient. I will write it outside. So 1 by pi into as extends to pi, limit of sine pi minus x by pi minus x. I wrote the remaining part of that question. Understood this part, my children? Understood this step? Here 1 by pi is a numerical coefficient. I write outside. Then I wrote the remaining part as extends to pi limit sine of pi minus x by pi minus x. Okay, my children? Understood this step? Right. In this step, if you substitute x is equal to pi, we get 0 by 0. That is indeterminate form. Previously I told you we should not get the limit of a function a indeterminate form. So if you get a indeterminate form, we follow some other method. Okay, my children? Right. So to evaluate the limit of this function as extends to pi, let us follow some other method. So put pi minus x is equal to y. Put y is equal to pi minus x. Let us assume that y is equal to pi minus x. This part is considered as y. Okay, my children? Right. So as extends to pi, then y tends to put x is equal to pi. Pi minus pi. What you get? Y is equal to 0. So y tends to 0. Understood this point, my children? As x tends to pi, y tends to 0, because in this equation put pi x is equal to pi, y is equal to 0. We get y tends to 0. Understood this step, my children? Right. That is equal to 1 by pi, y tends to 0, limit here as x tends to pi is there. In the place of as x tends to pi, we are writing y tends to 0. Understood this part, my children? Right. Limit of sine pi minus x. Pi minus x is considered as y. Sine y by denominator is also pi minus x, y. Understood this part, my children? Right. If you observe this function, it is in the standard limit as x tends to 0, limit sin x by x, where x is equal to y here. Isn't it or not, my children? Right. So it is equal to 1 by pi into 1, because as x tends to 0, limit sin x by x. This is a standard limit. By using this standard limit, you got the limit of this value. What is the limit here? 1. Okay, my children, understood this step? Right. Now let us simplify this one. That is equal to 1 by pi into 1. We get 1 by pi. Understood, my children? Right. Now come to the question number 17, my children. 17th question. Evaluate as x tends to 0, limit of cos 2x minus 1 by cos x minus 1. Okay, my children? Understood the question? We have to find the limit of this function as x is approaching to 0. Okay, my children? Right. Come to the solution part. As x tends to 0, limit of cos 2x minus 1 by cos x minus 1 is equal to, if you apply substitution method, we get 0 by 0. That is indeterminate form. Okay, my children? We get the limit of this function as 0 by 0. That is a indeterminate form. So previously I told you we should not get the limit of a function should not be indeterminate form, 0 by 0 or infinity by infinity, infinity minus infinity. You have studied 7 indeterminate forms. We should not get any one of these forms. But here if you substitute x is equal to 0, we get here 0 by 0. That is indeterminate form. So we follow some other method. Okay, my children? Right. As x tends to 0, limit of, let us take minus common from the numerator and as well as in the denominator. So minus of, what we get here? We reverse the terms. So 1 minus cos 2x whole divided by, if we take minus 1, then we get 1 minus cos x. Understood this step, my children? I have taken minus 1. We have taken common factor minus 1 from numerator and in the denominator. Then we get minus of 1 minus cos 2x by minus of 1 minus cos x. Just we write in the reverse order. First term is written as second term is written as first term. Okay, my children? Right. Here minus minus gets cancelled. That is equal to, as x tends to 0, limit 1 minus cos 2x from the trigonometry functions. In that chapter you have studied 1 minus cos 2x is equal to 2 sine square x. In the numerator we can write 1 minus cos 2x is equal to 2 sine square x. Similarly, in the denominator 1 minus cos x can be written as 2 sine square x by 2. Okay, my children? This is called half angle formula. This is a multiple angle formula. Okay, my children? Because in the numerator, NR stands for numerator. 1 minus cos 2x is equal to 2 sine square x. dr stands for denominator. In the denominator, we use this one. 1 minus cos x is equal to 2 sine square x by 2. By using these two formula, in the numerator we used this formula and in the denominator we used this formula. Then we got this step. Understood this step, my children? Right. Now strike out 2. Okay, my children, what do you get here? As x tends to 0, limit sine square x by sine square x by 2. Okay, my children? Understood? Right. Now, let us divide the numerator and denominator by x square. Okay, my children? Because square is there, sine square. Here also sine square. So, let us divide the numerator and denominator by x square. So, as x tends to 0, limit sine square x by x square. At the same time, simultaneously I am taking the limit of the numerator separately and the denominator also separately. As x tends to 0, limit of sine square x by 2 by x square. Understood this step, my children? I divided numerator and denominator by x square. At the same time, I am taking the limits also separately. Understood this step, my children? Right. This can be written as x tends to 0, limit sin x by x whole square. Because square is the sin square x, here also x square. So, sin x by x whole square. Okay, my children? Understood? Right. Similarly, denominator, as x tends to 0, limit of sin x by 2 by x whole square. Because the numerator also square, denominator also square. So, we can write sin x by 2 by x whole square. Understood this step, my children? Right. Now, if you observe the numerator, this is a standard form. And this is also a standard form. Okay, but it's standard limit. So, what do you get? Numerator 1 whole square by, here as x tends to 0, sin x by 2. Okay, my children? What is k here? 1 by 2. So, 1 by 2 whole square. Understood this point, my children? I will write that formula, because in the numerator we use this standard limit as x tends to 0, sin x by x is equal to 1, and in the denominator as x tends to 0, limit sin kx by x is equal to k. What is here? Coefficient of x 1 by 2. So 1 by 2 whole square. Understood this denominator, my children? Right. That is equal to 1 by 4. Understood this step, my children? Right. Then what you will get if you take the 1 by 4 to numerator 4. So this is the limit of the given function as x tends to 0. Understood, my dear children? Right. Now come to the next question, that is question number 18. Evaluate as x tends to 0 limit of ax plus x cos x whole divided by b sin x. Okay, my dear children, understood the question? We have to find the limit of this function as x is approaching to 0. Right. Come to the solution part. As x tends to 0, limit of ax plus x cos x by b sin x. Okay, my children. Right. If you try to apply substitution method, if you apply the substitution method, means if you put x is equal to 0 in this function, we get 0 by 0. Okay, my children. So substitution method is failed. Here we get 0 by 0, the limit of this function, a indeterminate form. So we have to follow some other method. Okay, my children. For every question, when you are evaluating the limit of a function, first and foremost method is substitution method only. If it is failed, if that method is failed, then you go to some other method. Okay, my children, understood the point? Keep this point in your mind, my dear children. Right. Now I will divide the numerator and denominator by x. And moreover here, b is a numerical coefficient. I will write it outside. 1 by b as x tends to 0, limit, I am taking the numerical coefficient outside. At the same time, I am dividing the numerator and denominator by x. Then what will you get? Ax plus x cos x by x whole divided by sin x by x. Understood this step, my children? I divided the numerator and denominator by x. Here 1 by b is a numerical coefficient. I wrote it outside. Understood this point, my children? Understood this step? Right. That is equal to 1 by b. Now let us take a numerator separately, denominator, limit. So as x tends to 0, let us split into two fractions. What will you get? Ax by x plus as x tends to 0, limit x cos x by x. I am taking the limit of every term in the numerator separately. Similarly, as x tends to 0, limit sin x by x. Here also in the denominator, I am finding the limit. Okay, my children, understood this step? Right. Here if you observe, x gets cancelled. Here also x gets cancelled. That is equal to 1 by b into, as x tends to 0, as x tends to 0, limit of a. Is there x is there? Not. So we need not to substitute x is equal to 0, a only. This is a constant function. So limit of the constant function is always constant, that constant only. Understood this is term, my dear children, first term. Right. Now plus as x tends to 0, limit of cos x. Now we use substitution method, cos 0. Cos 0. Okay, my dear children, understood the second term. Right. Now come to the denominator. This is the standard limit. As x tends to 0, sin x by x is equal to 1. In the denominator, we used this standard limit. dr stands for denominator. In the denominator, we used this standard limit. As x tends to 0, limit of sin x by x is 1. Understood this denominator, my dear children? Right. That is equal to 1 by b a plus, what is cos 0? What is the value of cos 0? 1 by 1. Then what will get here? A plus 1 by b. This is the limit of the given function. Understood, my dear children? Right. Now come to the question number 21. I am not explaining question number 19 and question number 20, my dear children. Please try yourself the question number 19 and question number 20. Will you try that questions, my dear children? Try them. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children? Right. Now come to the question number 21. Evaluate as x tends to 0 limit of cosecant x minus cot x. Understood this question, my dear children? We have to find the limit of this function as x is approaching to 0. Right. Come to the solution part. As x tends to 0, limit of cosecant x minus cot x is equal to. Here, if you substitute directly x is equal to 0, means if you apply substitution method, here we get infinity cosecant x, cosecant 0, infinity, minus cot 0, infinity. We get infinity minus infinity. Understood, my dear children? In the substitution method, we get the limit of this function is infinity minus infinity, which is also an indeterminate form. Previously, we discussed at this point. The limit of a function should not be an indeterminate form. So, in case we get an indeterminate form, then we have to follow some other method. Okay, my children? Right. That is equal to, as x tends to 0, limit, I will write cosecant x as 1 by sin x minus cot x, I will write as cos x by sin x. I wrote this first term cosecant x as 1 by sin x. Can we write it or not, my dear children? Right. Minus, I wrote cot x as cos x by sin x. Can we write this second term as cos x by sin x or not, my dear children? Right. From the trigonometric functions, we learnt these trigonometric ratios. Isn't it or not, my dear children? Right. Now let us simplify. Let us take LCM. That is equal to, as x tends to 0, as x tends to 0, limit of, what is LCM here? Sin x. Then in the numerator what we will get? 1 minus cos x. Understood this step, my dear children? Right. As x tends to 0, limit of 1 minus cos x. What is the 1 minus cos x value? 2 sin square x by 2 of angle formula. Previously we have applied this formula for the previous questions. By similarly here we write of angle formula, 2 sin x by 2 cos x by 2. This is also called of angle formula. In the numerator we applied 1 minus cos x is equal to 2 sin square x by 2. In the numerator, this is standing for numerator. In the numerator, 1 minus cos x is equal to 2 sin square x by 2. This is a off angle formula. Similarly, sin x in the denominator, sin x is equal to 2 sin x by 2 cos x by 2. In the denominator also we used off angle formula. Understood this point, my children? Understood this step? Right. Now let us simplify numerator and denominator. Here sin x by 2, 1 sin x by 2 gets cancelled. Okay, my children? Then what we will get? As x tends to 0, limit sin x by 2 by cos x by 2. Understood this step, my children? Right. As x tends to 0, limit sin x by 2 by cos x by 2. What can you write? Tan x by 2. Isn't it or not, my children? Right. Now we go to substitution method. Put x is equal to 0. Then what will you get? Tan 0. Tan 0 value is 0. Tan 0 by 2. That is tan 0. That is equal to 0. By substitution method. By substitution method, we got this step. We put x is equal to 0. We substituted x is equal to 0. Then we get tan 0 by 2. 0 by 2 means 0 only. Tan 0. What is the value of tan 0? 0. So this is the limit of this given function. Understood, my children? Right. Please try the question number 22. Question number 22. Okay, my children. If you have any doubts, ask your doubts and get your doubts clarified. With the help of previous knowledge, do the question number 22 also, my children. Okay, my children? Right.